is that it's non-relational in nature. It does not have any schema, or uh, it has some relaxed schema. So that the thing is that data definition is not part of the. You need not define the type of the data to be stored in a NoSQL database. It uses simple API, REST API and JSON API for storage and querying the data. And finally, distributed. So the data is available in multiple nodes in a distributed fashion. So even if one node fails, I will be able to work with the other nodes, right? So here you have the ACID properties are being sacrificed for scalability and throughput. It does not guarantee consistency, but it provides eventual consistency, right? So last class we have done with this categories of NoSQL databases, right? So the first one is going to be key value pair based NoSQL databases. Saloni, can you explore something more about key value pair based NoSQL databases?
Yes, sir. So all the data is stored. One, there is a key, and that particular key has a value. So in this way, a lot of data can be stored, and so it's stored in form of hash tables. And if it is key value, then key has to be unique. Yeah, the second point, I think. So this is how it's stored in JSON, blob, etc. So key has to be unique, and value can be the same. And yeah. I think that's it.
Right.
For an example, if shopping cart contents are there, then the probably item name or item ID, some sort of that can be the key, and that value can be the description. So that can be one example.
Right. So this kind of databases are like you can visualize as dictionaries. You have some key value pair, right? Some keywords will be there, and you have some value in a dictionary. So this kind of database is used as a collections, dictionaries, associative arrays, and so on. Redis, Dynamo, and Reoc are some of the popular examples for key value pair based NoSQL databases, right? So this is how it looks like. So here name is a key and the corresponding value is Joe. Age is a key. The value is going to be 42 and so on, right? So you are going to organize the information in the form of a key value pair. So this is one way of representing the data in NoSQL databases. The other is like we'll be using some column based databases, right? So every column is treated separately, and values on single column databases are stored contiguously. So here it is very easy for you to run some statistical operations on the columns, right? So you'll be able to perform some aggregate operators like sum, max, min, count, average on the data that is readily available in the column, right? So it is used to manage data warehouses. So this column oriented data bases or NoSQL databases, they are used to construct a data warehouse. So what do you mean by a data warehouse? Udit Kumar, what do you mean by a data warehouse?
Hello.
Yeah,
Yes, sir. It's just a place where we store large amounts of data.
right. So it's a place where you store large amount of data. Yeah. So it's a like a normal warehouse, right? So where you store large data. So like a warehouse, data warehouse, I can define in some keywords. It's a subject oriented, integrated, non-volatile collection of data, right? So data warehouse is a subject oriented, integrated, time variant, and non-volatile collection of data. So subject oriented in the sense that it is organized on the major subjects in an organization, right? So who are the major subjects in any organization? The customers, the vendors, the employers, right? So the product details, right? So it's subject oriented. So data warehouse is an integrated system. So integrated in the sense that you are going to integrate data from multiple data sources that are spread across different geographical location, right? Again, a data warehouse is a time variant system. So the information is stored in a data warehouse over a period of time, at least 5 to 10 years, right? So the information we call something as a data warehouse if it can store the information over a period of time for at least 5 to 10 years. And it's a time variant system. It's a non-volatile system. It's a stable and a predictable system, right? So this is how we define a data warehouse, right? So it's used to store a large volume of data. However, the important properties of data warehouse is that it's a subject oriented, organized on the major subjects in an organization, right? Maybe when you design a data warehouse for our institute, you will have student as a subject, faculty will be a subject, department will be a subject, courses will be a subject, and so on, right? So it is organized, it's a subject oriented, it is organized on the major subjects in an organization. So integrated, so you are going to integrate data from multiple data sources, which may be in different formats, which may be spread across different locations, and so on. And time variant, so we say something said as a data warehouse if it contains information for a period of at least 5 to 10 years, right? It should contain some information with respect to time constraints, and it's a non-volatile, in the sense it's a stable and a predictable system, right? So for constructing this type of data warehouses, business intelligence, doing some business intelligence, right? So data warehouse will do a lot of business intelligence activities. We can perform a roll up operation. Roll up means given monthly sales, I can compute the yearly sales of your product, right? So given the quarterly sales of your product, the quarterly sales of your product across different quarters, I can compute the yearly sales. It's known as roll up operation. Drill down operation means given the yearly sales of your product, I can find the monthly sales of a particular product. It's known as a drill down operation. You have some other operations known as slice operation. Whenever I'm going to select some data in a data warehouse based on a single attribute, it's known as a slice operation. So dice means I will be able to retrieve information based on more than one dimension, 2 dimensions. It's known as dice operation, and so on, right? So we'll be able to perform some business intelligence operations, customer relationship management, managing library code catalogs using this column-based NoSQL databases. So here the popular NoSQL databases are HBase, Hypertable, or some of the popular examples of column-based databases, right? So this is how column-based data is organized. So you have your row key, then you have your column name where you have some key value pair, and the next is like document oriented databases. So in today's class we'll work with this MongoDB, which is a popular document oriented NoSQL databases. So again, here you are going to store the information as a key value pair, but the thing is that the value pair is stored as a document, right? So again, the document is stored in JSON or XML format. So the document type is mostly used for content management system, blogging platforms, real-time analytics, and e-commerce applications, right? So once we work with the MongoDB, we'll study how it is being organized. And finally, graph-based NoSQL databases. So whenever you have a graph-based system, you have a graph-based system is represented by nodes and edges, where the nodes, they are used to denote an entity, and the edges, they are denote the relationship between the entity, right? So yeah, an entity is denoted by means of nodes in the graph-based NoSQL databases, and the edges, they are used to represent the relationship between the node. Every node and edge, they have some unique identifier, right? So compared to relational databases where tables are loosely connected, a graph-based database is a multi-relational in nature, right? So this is how so a person has some friends, he likes a particular product or a service, he likes a particular city, right? See, he likes some restaurant, he has given some numeric and text ratings for a particular restaurant, right? So the person lives in a city in a particular address, right? So the restaurant is located in that particular city and so on. So you'll be able to represent data which is multi-relational in nature, right? Again, traversing a relationship is fast and they are already captured into the database and there is no need to calculate them. So graph-based NoSQL databases are used to represent social networks, spatial data, geographical data, and logistics information. So Neo4j is a very popular graph-oriented NoSQL database. Right. So this is what we have done with in the last class.